video on surface area is finding the surface area of composite shapes. A composite shape is a three-dimensional shape made up of two or more three-dimensional shapes. So composite root word is compose, and compose is to make up. So these can get a little bit messy. So we have to think of some key ideas. So I have a few key ideas. Key idea number one is we really want to identify the shapes we're looking at. Key idea number two then would be to identify the formulas you're going to use. And remember from the last two tutorials, some formulas are nice and organized for us, and some of them are the old messy grade 8, grade 7, grade 6 formulas. And finally, and probably the most important, is organization. So in looking at this shape right here, I hope what we see is we see a rectangular prism and well, a half of a cylinder really, but it's a cylinder. And in going ahead and planning our strategy, remember what we have to think about with surface area. We're going to imagine dunking this in a paint bucket, and whatever gets coated is what we need to calculate the surface area for. It doesn't matter which one you work at first. So I'm going to start at the bottom and go to the top. So I'm going to look at the prism first. And what I want you to see is, again, with the prism, we just have to figure out the area of all the faces and bases. So here's what I want you to understand is the top, if we imagined, it didn't have a cylinder on it, would have a top. But given that the half cylinder is plonked on top of this, paint will not touch the area I've just highlighted. So again, in this prism, there is no top. So when we go to calculate the surfaces, there's only going to be 5 surfaces. There's going to be the bottom, there's going to be the front and the back, and then there's going to be the right and the left-hand side. So again, organization becomes important. So I'm going to identify what I'm going to try to find. So the bottom. And the bottom we can't really see, it's not dashed out, so I'll just quickly do this. So here's the bottom bit right there, and that's what we're going to calculate. And in calculating the bottom, it is just a rectangle, and here's our formula for a rectangle. And I'm not going to put the units in right now. I'm going to leave the units till the very end because I don't want it to get messy. So again, organize your brain. So there's the bottom. Then we have, I'll call it a left and a right. And this would be this face right here and this face right here. So this is what I mean by left, right. Again, this is my notation. I've made some decisions, and you're going to have to make these as well. So in this one right here, well, the height of that rectangle is 8, and the length of it is 13. So we're going to have 8 by 13, which is 104. But again, we have 2 of them, so there's our double 2/8. Similarly, we're going to have the front and the back. So again, here's what I'm looking for here. Here's the front, and there's the back. And in doing that, we have the same idea as above. We have a 7 by 8 rectangle, which is 56, but then we have two of them, which is 112. And when we add those all together, we get 411. And I'll put my units here because I'm pretty much done with that. So again, organization is really important, and realizing what formula you need to use is important as well. Okay, so we finished with the rectangle, and now we're going to the cylinder. Now, it's a half cylinder. So what do we have in this cylinder? Well, I'm going to identify it right now. I'm going to call these the ends. You could call them the front or the back, right? And then we have that thing called the lateral side, and that lateral side, remember, it goes to the back, right? So this is what we need to calculate. So with our cylinder, you could call it a half cylinder or whatever, but again, what I want you to notice is there is no underneath to this cylinder. So in doing our cylinder, I'm gonna look at the side first. And in looking at the side, again, that's the lateral side, and we have a formula for that. And remember the formula for surface area of a cylinder is equal to 2 pi RH plus 2 pi r squared. And this is the side, and this is the end or base, whatever you want to call it. So in this one right here, we have 2 times pi, and again, we could use the pi button or 3.14. And then we have the radius. Well, again, we don't have the radius, but what we do have is we have 7 millimeters, which represents the diameter of that cylinder. And remember, radius is half diameter, so half of 7 is 3.5. And again, that cylinder is 13 millimeters long. So here's our formula, and that would be a formula that we would use to figure out the surface area of the side or the outside if we had an entire cylinder. And I'm going to round it to 1 decimal place, but remember, we only have half. So we're going to have to divide by 2. And that's important. And when we divide by 2, I'm going to round it. We're going to get to 142.8. Okay. So there's the surface area of the side of our half cylinder, and now we want to do the ends. So in doing the ends, again, the formula would be pi r squared, right? For one of the ends, but then we'd have to divide that by 2 because we don't have a circle. We only have a half a circle. But to make our life easy, what I hope you can see on the other side is on the other side we have another half circle. So if we divided by 2 and then we multiplied by 2, that's the same as simply going, hey, we have a half circle here and a half circle on the other end, and that makes an entire circle. So we can make our life easier just by understanding the picture. That would be very valuable. So then the end becomes pi times 3.5 squared, and that equals 38.5 rounded. And then our total area would be 181.3 square millimeters. And that would be the surface area of the ends and the curvy side, the lateral side of the top cylinder. And finally, in order to figure out the total answer, the total surface area is equal to the surface area of the prism plus the surface area of the cylinder, and when we add those two together, we get this many square millimeters. So again, key ideas: identify the shape, identify the formula, and organization, keeping track of what you've done.